Okay, cool. So, hello, I'm Ruben. Uh, I'm actually curious, how many of you know me? That's more than I expected, so that's great. So I'm a researcher at VUB, working on some interesting cryptography-related things. And that's why I come to talk a bit about instant messaging and Signal and Sailfish and well, that's a bit a theme going on, and there is a lot of hectic, different stuff, kind of things going on in the slides. So we'll have a look. So what am I going to talk about? Well, I'm going to talk about talking. People like to talk to each other, and how do you do that usually? Well, if you're next to each other, you just say something, and usually that means that well, the message arrives and nobody else has heard that, and nobody else even knows that this conversation is taking place. If I'm in my apartment with someone and I talk to them, this happens off the record. This doesn't, there is no one else that knows that this conversation has taken place, except maybe if you have something like a Google Home or an Alexa or something. So in real life, it's pretty easy, you just shout. But what happens if you're far away from each other? For instance, I want to send a message from here in how did you? Lausanne. From Lausanne to Belgium, back to Brussels. How do you do that if you have, for instance, you have a phone? Want to send a message to someone else? How do you do this? It's not so easy because, well, the phone now has a record and the other phone also has a record, and it's a bit more interesting. And basically that's what we're going to talk about today, what happens between the two phones. That's something really interesting to me. So let's zoom in a bit. First I'm going to talk a bit about end-to-end encryption. It's something I think like 90% of you people will basically know. Like, how many of you know what end-to-end encryption more or less means? So that's 90%, yeah, cool. It basically means that instead of sending the message here in plain text from one phone to the other, you're going to encrypt it in such a way that what happens in between the two phones, if there is someone listening in, you can't see what the actual message was. That's end-to-end encryption. And usually, how is this message transmitted? Well, there is some server in between or some evil cloud in between, and this evil cloud cannot read the contents of the message. That's the idea of end-to-end encryption. But what happens in the cloud, of course, stays in the cloud. And there are many, many other things that can go wrong. Let's first talk about the good stuff about end-to-end encryption. So end-to-end encryption offers you confidentiality. The message that I send to Brussels will arrive in Brussels probably, and will be intact, and it will be confidential, and nobody else but the recipient will know what the content of the message is. That's the confidentiality. Also, something interesting in most basically all the end-to-end encrypted systems is forward secrecy. This means that if somehow someone intercepts key material, then at best they can basically decrypt one message, and everything after that should be still fine. You need to basically intercept the whole conversation from the beginning of time in order to compromise future sessions. That's the idea about forward secrecy. So that's good. It's really nice. But what happens with metadata? Because if I transmit a message now, well, the server will know that I transmitted a message, and it will also know that this same message arrives someplace else. And, well, basically this evil cloud now knows that I'm talking to someone. I am talking, and they know to whom I'm talking to, and that's a bit annoying. They also know from where the messages are sent. I have an IP address, the server knows my IP address, they know I'm in Lausanne. It's also something interesting. What about groups? If you have a group messaging system, the server, maybe they know about the structure of the groups. So these are all interesting metadata things, and basically what I'm claiming here is end-to-end encryption is just a bare minimum thing that we all require. It's a basic requirement. Yeah? We need way more things in order for real off-the-record messaging. And that's what I want to convey today. So who of you knows Signal? And who of you uses Signal? Yeah. High correlation between the two. So basically, Signal, those people are the pioneers in secure messaging. They're well known for the end-to-end encryption system that they developed. And they also, well, basically they sold it to WhatsApp. WhatsApp uses the same protocol for end-to-end encryption. And Signal is very interesting because it's extremely easy to use. I can call my grandparents today and tell them, hey, can you install this app? It will take you 1 minute and it will work, and you will be securely messaging everyone from that point on. Everyone that also has Signal. That's really nice about Signal, but there is a lot that's different from the competitors that I would like to address today, and I'm going to come off as a fanboy today. So please do ask me questions and I'll try to be very defensive. But they really differ a lot from competition, and that's let's see where they differ, because this is something interesting from 2018. So 4 years ago, Signal decided, well, it's not really cool that we know that Alice and Bob are talking to each other. We shouldn't be able to know that. No? So they came up with an interesting system, and they call that sealed sending or unidentified sending. And the idea is pretty simple, but let's first look at the standard end-to-end encrypted system. Basically what happens if Alice wants to send a message to Bob, what do? They do their end-to-end encryption thingy, they put it in an envelope, they put it in the cloud, and the cloud says, okay, thank you, Alice, I'll forward this to Bob. And then the cloud knows there was a message from Alice to Bob. That's what happens here. Very simple, okay? So that's the baseline. What is sealed sending? Basically, Alice wants to send a message to Bob, and what they do instead is they say to the server, hey, I know Bob, but I'm not going to tell you who I am. Just deliver this thing to Bob, please. And in the real world, this works. It's like a postal office. You go to the postal office, you have an envelope, you put it in the letterbox, and you don't really have to write on the back of the envelope who you are for the return. It will just arrive, and the postal office will not know who you were, right? This is the same principle. You just don't tell the server who you are. But this has a very annoying implication in the digital world, because it's extremely cheap to send messages. So you have things like spam, you have impersonation attacks, all these kind of things can happen. And that's basically the thing that Signal tried to solve in 2018, and they did a pretty good job. And I'll explain you a bit how it works. So in the second phase, well, the server can just say, hey, I got a message from someone, I don't know who it was, but they claim to know you. Here is the envelope, and please read it. So there are two main things that you need to be aware of here. It's the spam kind of factor, the fact that you can just dump as many messages as you want to the server. And there is the impersonation kind of thing. And both things are basically solved in the sealed sending protocol. So the idea is sealed sending will hide who is sending messages from the cloud. So yes?
Hides the sender as is, like the sender doesn't tell it's me. However, the sender will send the IP address, the location, and stuff to the cloud. This is not addressed by this protocol.
No, the protocol does not address the fact that the IP address is still there and all these kind of things. But in principle, this does allow you to contact the Signal servers via something like Tor or something else, or a VPN, or I don't know what. So in principle, that's possible, and that's actually something that's been in the back of my head for a long time, but to integrate Tor into Whisperfish would be really cool, specifically for this. Tweets. So sealed sending will hide who is sending messages, such that the cloud will not see who is sending the messages. I've stolen some slides from previous presentations, so it might be a bit misfit, but basically what what happens in a more decentralized setting, for instance in OAuth, you can also do something like this. You can request a credential from somewhere and then after the fact prove that you have some kind of an identity that's been proven by someone else. So this is the basic idea. I get a credential from Signal and later on I can use this credential to show them that I'm behaving in an honest way. That's the base idea. Okay? So kind of a certificate, I request a certificate from Signal and when I'm sending a message I can use this certificate instead of showing my true identity. But the problem is if Signal is issuing the credential and they will also check the credential, well, they can correlate the two. So you need some kind of a technique to hide this. And this is what's a typical application for a zero-knowledge proof. So what Signal basically did is they made a very specific zero-knowledge proof for their sealed sending problem, such that, well, the moment that you send a message, you just prove to the server that you know Bob or that you have permission from Bob to send a message. Next slide I'm going to detail a bit what zero knowledge can do. But basically in essence what you do is when you want to send a message to Bob, you go to the server, you throw them some random looking data that they cannot know what's actually happening there. And the only thing that they can see in this random data is apparently the person that sends this message knows Bob and they have permission from Bob to send a message. And basically zero knowledge proofs allow you to do this. So they basically allow you to minimize some kind of a statement. I have some, for instance, a very simple, a very interesting zero knowledge proof would be to use Belgian identity cards. I'm not gonna show the back because that's confidential information apparently according to the Belgian government, but I can show the front. There is a little chip in here and the chip contains an RSA certificate and the RSA certificate says I'm Ruben de Smet, I'm born in 27 years ago, born in some kind of a city, my nationality, a card number, validity of the card, all those things are signed on an RSA certificate. But it is one big monolithic certificate. And let's say that I go to a grocery store, although in Switzerland that's maybe a bit of a weird thing to say. I go to some kind of a liquor store, because I know there is a grocery store that doesn't sell alcohol, so specifically liquor store. And I want to buy a bottle of wine. And I look maybe underage. And the people at the liquor store say, please show me your identity card. And I say, no, I can't do that because the back contains confidential information and I'm not allowed to show you from the government. There is kind of a conflict going on there. I cannot show you my identity. I don't want to show them my identity. They don't have any business with the fact that I'm Ruben. They don't have any business with the fact that I'm from Belgium, right? They only have business with the fact that I'm over 18 years old. So what I could do is show them like this, right? That's what I could do, but that's a bit annoying. But that's basically what a zero knowledge proof does, right? It allows you to extract this RSA certificate, make some derived statement from it, and show them that I'm over 18 years old. By the way, I can't do that by just putting my fingers over there because they will still know my birth date. They will know that I'm 27 years old instead of 18, right? A zero knowledge proof actually allows you to make some kind of a formal proof that convinces this store that I'm actually over 18 years old. It's something we're working on at the university, specifically with the Belgian EID, by the way. Okay, so how does it work? You take your identity card, you take a meat grinder, you do like that, and out comes a proof, and you can show that to the liquor store and they will be convinced of the fact that you're over 18 years old. Yeah, something interesting in the footnote here is this is probably a very interesting technology from the GDPR standpoint, because the GDPR, they basically require you to minimize data. Yeah? There is a statement in there that says if you have the technological means and it's practically and commercially viable to do, you have to use technological means to minimize data. I'm not citing it very well here. At this point, commercially viable is still a bit of a difficult thing, but it will become commercially viable to do really, in a really easy way, these zero knowledge proofs, to make them efficiently and cheaply. And at a certain point, it will be basically mandatory to use them. Very probably in the near future, especially because Signal can do it apparently. Okay, so Signal uses a zero knowledge proof. In the client application, it generates a proof. It shows to the server, I know Bob. That's basically what it does. So few interesting things that you can do with them. It can make me prove that I'm allowed to drink beer. I can prove that I'm allowed to vote. I can prove that I can access some part of a database, for instance. It's also something interesting, without revealing the actual data that's behind it. Cool. So that's one thing that Signal does from a very interesting standpoint, sealed sending. Second thing that I want to talk about is about groups, group messaging. Basically, in instant messaging, you have two big paradigms of how you do group messaging. First paradigm is server fan-out. This means Alice wants to send a message to the family group. She will generate this message. She will send one copy of the message to the server and tell the server, hey, give this to the group. And the server says, okay, group, this is the group structure. So Alice was in the group, and I know Carol, Dave, and I'm sorry, I forgot your name. No, Carol? No, it's not Carol. Charlie, Dave, and Bob. Bob, obviously. So this is Bob. That's Bob. That's Charlie. That's Dave. Yeah, that's what. Okay. So the server knows the group structure, and the server will distribute the message to this group. So Alice sends one copy, and the group receives the message. That's the idea. That's server fan-out. But now the server knows the group. Do we want the server to know who's in the group? I wouldn't want that. Okay. So how do you solve that? You solve that by the second big paradigm in group messaging. It's client fan-out. Basically, what's happening here is Alice is sending n copies, so or n minus 1 copies for every remaining member of the group. She creates a copy of the message and tells the server, hey, give this to Bob, give this one to Charlie, and give this one to Dave. That's the concept. And then the server does not necessarily know the structure of the group. You could argue that the fact that those three messages arrive at the exact same time is a bit annoying, but then again, you could use like 3 Tor endpoints and give them in a sealed sending way to the server, and then they are basically not really correlatable given the amount of messages that Signal receives on a daily basis, right? So that's the concept of client fan-out. And obviously, in this case, Signal went for the second approach because of the privacy implications. But it has some very non-obvious disadvantages. So a very obvious disadvantage is the fact that you have to send n copies of the message. It's very annoying. It also means that things can become inconsistent. If I send a message n minus 1 times and I forgot about some group member, they won't see the message. And Whisperfish does that a lot. Well, a lot happens. But there are other very non-obvious disadvantages, because if the server cannot enforce the structure of a group, then it's basically anarchy. Yeah? If I add a member to the group, I can just do that. I can send a copy. Just works. Yeah? So in before 2019, this is what happened. If a group needed an update, a group needed a new member, then you just add the new member. Everyone could do that. Everyone is basically an administrator of a group. And if you miss some messages, for instance, I add a group member, but Whisperfish is a bit buggy. I added a group member, but the message didn't come through to someone, then they don't know that there is a new group member. That's sad. Okay, and they will never know unless someone else sends them the update again or something like that. So these kind of inconsistencies, they happen in the client fan-out paradigm, basically. What happened in 2019? Signal said enough is enough. We're going to change this, and we will store the state of the group on the server in an encrypted way. So we basically, the administrator encrypts the structure of the group, puts it on the server, and we will store it there so that if you're joining a group, you can just download it from the server, easy. If you want to make sure you have a consistent view on the group, you can just download it from the server again. That's useful. And if the administrator wants to change the structure of the group, they will use a zero knowledge proof, again a very tailored kind of zero knowledge proof, to prove that they have the rights to modify the group structure. So in this case, in this setting, you basically have the difference between administrators and between administrators, moderators, and just users of a group. So the anarchy aspect is gone in that regard, basically. And the administrators can do this without identifying to the server who they are. They just say, hey, group number blah blah blah, please change entry 3 with this one. And here, by the way, is the proof that I'm allowed to do this. And never does the server know what happens there. And I can feel the question that you were about to ask. If you store the group state on the server, then that means every time you update the group structure, every member will need to download it again from the server. And then the server again knows the group structure because you can correlate those requests. But not in Signal. Well, not necessarily in Signal. Whisperfish does it like that. So Whisperfish does not do the peer-to-peer messaging. But what happens in normal Signal is you distribute the structure and the changes of the structure to the participants of the group directly. So the administrator wants to add a new member to the group, sends a request to the server, hey, add this entry. And the server signs this, and they say, okay, this is done. Here is a signature from the server. I have done this. And they send that back to the administrator. And the administrator can now just send this signature together with the group delta, with the addition, to all the existing group members. And the existing group members will say, oh, this is a valid signature from the server, so it's basically done. So this is a valid change of the group structure, and we will retain the change, and we will not have to contact the server for this update. That way, you don't have to contact the server anymore for the update. So you validate it against the server signature. And there are many more interesting things happening in Group v2. This is basically how it was in 2020. 2 weeks ago, Signal broke some stuff for Whisperfish again, so there is way more interesting stuff happening again in the group system that I have still to figure out, basically.
One question about messages inconsistencies. Imagine, so if a client fan out, and the client couldn't send a message to one of its members, Group v2 doesn't address that, right?
Sorry, then?
Group v2 doesn't address the fact that you can lose messages.
Yeah.
Since you need to contact every member to send them the message.
Yeah, indeed. So Group v2 does not address the fact that if someone misses a message because I couldn't send the message, for instance, indeed. That's something that's solved client-side, basically. So the client will have a message queue, and for every copy of the message, they will remember whether it was sent and received, and if not, it can retry these kind of things. Once again, Whisperfish doesn't care. Okay. Yeah. So let's talk a bit about Whisperfish. So what is Whisperfish? Most of you know Signal, most of you probably don't know Whisperfish, so let's introduce that a bit. So for Sailfish, Whisperfish is a Signal client. It's a third-party client, and it was originally started by Andrew Bruno in 2016, and he wrote this in Go. Why in Go? Because there was a library called TextSecure in Go that implements the end-to-end encryption protocol of Signal. So back in that time, that was basically all you really needed to create a Signal client. So Whisper Phishing Go, and it worked. Even in 2019, it worked, and I'm quite sure many of you used it back then. At least I did. I enjoyed it. But Andrew decided to step down in 2019 because it was a big maintenance burden. It really is. And he decided to step down. And in July, I said, let's rewrite this in C++. Sorry? Because why not? Well, because basically all the Signal libraries themselves, well, the thing was you had TextSecure written in Go, but it was not really maintained. Yeah, it became a bit out of sync. Signal had a library in C, and it was way simpler to just say, well, 90% of Selfish OS is in C, C++. It's cute. Why would you go C, Go, and then back to? It was a bit complex. So I said, we should be as close as possible to upstream Signal. Let's use C++. I don't like C++. It was a bad decision. I didn't like it. And I switched to Rust. And a few weeks later, Signal also switched to Rust. So I don't know whether it was visionary or something like that. I don't know. There was someone, Michael F. Bryan, who had written the basically bindings for the Signal end-to-end encryption protocol, bindings to Rust. And in November 2019, we were working on that. And I started to create bindings for the REST API, the web API, together with Michael, and now a few weeks later together with Gabriel Ferron. And those two were built on each other basically, or they were meant to be used together. And then a few weeks later, Signal published their new libsignal client, which was basically the libsignal protocol library written in Rust, completely written in Rust. And then we switched over to the new Rust library. It was really nice, and that's why we decided to keep the Rust version. Well, no, the reason we decided was the headaches, but and then I did a very stupid, crazy thing in May. I basically integrated two event loops. I have a talk about that. If you Google a bit, or I can share a link or something. I have a talk about how I integrated the Actix and Tokyo event loop with the Qt event loop. Was very hacky. Back then it was very hacky. Now it's slightly less hacky. So now it's actually based on defined behavior instead of undefined behavior. And then throughout 21 and 22, there are various beta releases, and the reason that there are still beta releases is on the next slide. It's really, really a difficult thing to maintain. Yeah. By now, Signal has 40 full-time people working on the three platforms that they have. We are 2 people, but in practice 0.2 people, right? But I've listed some reasons. Rust used to not exist on Sailfish OS, so I did a very, 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 very hacky way of cross-compiling towards Sailfish OS, which worked for a year, and then Yola came up with their own compiler, and I was really happy about that. The Rust compiler is slightly outdated. For Rust people, it's outdated. Like in normal software development terms, it's 1 year old. It's not that bad. It's not so bad. Well, currently it's Rust 1.52. I have, no, it's not too bad, right? But the thing is, the Rust edition currently is 2021, and apparently there is this convention in the Rust community that bumping a Rust edition is a minor change. And then that means that if they have a minor change for Proc Macro 2, then suddenly nothing compiles anymore for us. So it's annoying. So I have a PR that I still have to update, but I think someone in Yola is taking it up by now.
Yeah, one of the real problems with the Rust compiler is that it's not really backwards compatible either. So we need it to compile Gecko because the Mozilla engine has now got a lot of Rust in it. So we're basically pinned to the minimum and the maximum version of the Rust compiler that will compile our current version of Gecko.
Yeah.
So we can go forwards a bit, and hopefully that will improve the stability of build Gecko, which is really cool. But we are, until we upgrade the browser engine again, which is like months of work, and we're fixed on that range.
Yeah, I realize the difficulties at Yola with Rust. Don't get me wrong, I really realize them.
But you know why a compiler isn't backwards compatible is just beyond me.
No, this I think is linked because Gecko is also at fault because they use unstable features.
Yeah, Gecko uses nightly Rust.
If
That's
you-
the issue.
If you're a nice Rust developer and use only stable things, I
Yeah.
guess usually all these things shouldn't really be a problem.
Yeah.
But
If
Gecko is the beast on its own.
if Gecko used stable Rust, there would not be a problem.
But it's their language, so they'll use whichever.
Yeah,
fits
they
their
use
style.
whatever they please. And it's a thing in the Rust community as a whole. Nightly compilers are very popular because it's so fancy, and it is.
Shouldn't be
It
the
is.
case,
I used to use a lot of nightly Rust. So
Did you know, Lucian, didn't you do the first build of the Rust
Yes,
package
I
on,
did
on the
very
community ops like years ago?
Yes,
So-
I took
Ah,
the
right.
6 hours of the ops build because you know you have to build a simulated ARM
Yeah.
QEMU in full because you know we use the build of CFJS use accelerators, so cross compiler. If you have the cross compiler at the beginning, but there is no cross compiler at the beginning, I couldn't make this work. So yes, we had to build for 6 hours.
You had to chain it, if I remember. You
I
had to
had
build
to
the next
chain it,
version
yes.
with the previous version, and then on and on and
It
on.
was
and on.
really great.
yeah. So that's why I decided not to take that approach, and I just used the basic cross compiler.
You use a cross compiler.
And then I hacked in all the ARC paths to
my
link to the SDK. So I had like this big shell script that set up all these paths and all these kind of weird linking things, and somehow it worked for a few years.
What the hell? What the hell?
So I was really happy when Yola said they were doing a Rust compiler. But then again, I had to make some changes to Cargo. There was a bug that was in Cargo, in the Yola version of Cargo, that I patched out. So I still, and to this date, I still run my own Rust C and Cargo, especially. But Yola, yeah, it's upstream by now. And I wanted to tell you why I'm still using my own compiler at this point, but I really don't recall. But that patch is upstream and everything is getting upstreamed, but it's basically a chicken and egg problem. Basically a cat and mouse problem. Cat and mouse, that's what I was looking for, because Singul is updating their libraries, so I have to follow them, and then I need a new Rust compiler, and so that's basically what's happening.
Doesn't respect MSRV at all.
They use nightly.
My gosh. MSRV minimal Rust version support.
Yeah, so they don't do minimal supported Rust version stuff.
Minimal support version nightly at today.
Yeah, basically
Alright.
they have like a Rust toolchain file, but I forked their library at this point to take out some really fancy features that they allegedly need. They don't need them, but yeah, the code is indeed a bit cleaner.
Okay.
See, so it's really a cat and mouse game. I have to follow Singul, I have to follow Yola, and it's a constant conflict. But this part is really going better, like basically every Sailfish release. So that's really nice. Qt is slightly outdated,
Slightly.
slightly. We know that. Not looking at anyone in particular. But well, basically what that implies for Whisperfish is every time that the Qt bindings that I use receive an update and someone added a new feature, I basically have to add a feature flag, or like a flag in the code. Yes.
There is a question from the internet. Does this mean Rust is working on Sailfish OS now?
Yeah, Rust works on Sailfish OS. Yola uses it internally for Gecko. I use it for Whisperfish. Rust works. It just works. I have a bare minimum GUI application if you want. It's called TAAK, T-A-A-K, which is a GUI front end for Task Warrior. And it's a very minimal application. It's not the best, but it's a very minimal working thing that you can use Rust to make QML GUIs, and it just works. Yeah, Signal used to be very hostile towards third-party clients. That's something annoying. But there is also an explanation for that. They basically didn't want third-party clients on their servers because, well, you don't know what they are going to do with real clients. What kind of messaging are they gonna do? So they used to basically ban them. Then they went towards a more community appreciative approach, I think, where there was the Libre Signal project, which was a fork of the Android Signal client. So the forked client, basically they didn't want Google Play services, obviously, but that's basically upstream now. So you can use the Signal APK and then you have a Google free Signal experience, basically. That's the thing. So they're really, and I feel like their hostility changed a lot. People used to blame Moxie. I don't think Moxie was to blame. It's a very politically difficult thing going on there, but they used to be hostile, and I don't think they still are. No. I'm in contact with Jordan Rose, for instance, on GitHub, now and then supplying patches. I promised him a lot of patches. He only got like 2 or 3 by now, but so there is some kind of they know about our existence. So I also explicitly advertise the user agents. So contacting the server is Whisperfish with a full version. So if they decide version 11 is bad, they can just ban it from the server if they want. They haven't done that since I've been running Whisperfish. So I think this is over. They don't explicitly claim that. So very important note. Yesterday on the train, I read the interview with the new president of Signal, and they explicitly say that they don't like this. So, well, they don't like the move fast and break things paradigm, obviously, because that's a Silicon Valley thing, and they don't really like that. But they still do, in my eyes, right? Every few weeks they have a new feature, and I love new features, except for the fact that I also have to implement them. And they do that a lot. Yesterday on the train, on Matrix, I received a message saying, hey, is it normal that I just registered my phone and people can't contact me? That was new to me, so Signal broke again. Yola moves fast and break things. Slightly slower, luckily, and slightly less often, especially in the Rust thing. I mean, but that's bearable. The fact that Signal moves so fast is really difficult. So basically, I want this to be a takeaway from the slide. Whisperfish is not as privacy friendly as upstream Signal because we don't implement all these fancy new privacy protecting features. I really want them all, but apparently I also only have 24 hours in a day. I really want them all. But if you need absolute privacy, use the Android application, please do, even on a Yola phone. If that's what you care about, use the Android application. If what you care about is I can chat with my grandmother, it's fine, okay? That's the takeaway from this slide, basically. And then a last thing I want to quickly go over is a few of the alternatives. I just realized that I'm talking for 40 minutes instead of the promised 20, but it's fine. Okay, so a few notes on alternatives. Like I've said in the beginning, I'm a fanboy. Apparently I am, but I still want to go over a few. Like Telegram, for instance. So especially this one in the middle. Yeah, they claim privacy, but take it with a big grain of salt, because by default chats are not end-to-end encrypted. So you can't claim that. Okay? You just can't claim that. If my grandmother is talking to my mom over Telegram, it's not private, because they don't know about the button for private chat. You also lose like half of all the features in Telegram if you enable it.
Won't work if you encrypt.
Sorry?
The synchronization that they claim on the
Yeah.
top
Yeah.
one.
Yeah, and the synchronization is just copy all the messages to the server. And it's really difficult. And then they're fighting a war with Signal. It's very, very bad idea. But okay. So that's for Telegram. But the purpose of Telegram is also slightly different, right? Like the bots aspect and the big groups, and the purpose is slightly different. But people move from Signal to Telegram because they say it's more private because you don't need to register with a phone number. That's a very bad argument, okay? Don't use that argument. I get really mad about it in the slide after this one. WhatsApp, something I want to talk about very quickly. They use the Signal end-to-end encryption protocol. Great, but that's all they do, okay? Everything else is just Meta and Facebook. Especially, I tried to read the features. I couldn't because I had to accept cookies on the website. Something interesting to look at is Session. That's something that tickles my interest a bit, because they use a very different paradigm of developing all these kind of things. They advertise the no phone number thingy. Okay, yeah, of course, the no phone number thingy is interesting. Because indeed, for Signal, you still, up to today, I think, you need a phone number to register with Signal. Yeah. I've read the source code a few times since 2019, like the Signal Android source code. And basically, technically speaking, it's not a requirement anymore. So the next few weeks to months, I expect Signal to release a new version of the application where you can register with an email address and a username. Like, it's weeks from now, because the code supports it. The registration endpoints exist, everything like that, it exists. It's just enable it in the GUI, basically. So I expect them to do that. And I expect Whisperfish to break over it again. So we already broke over that 3 times, over the fact that they're migrating to not having phone numbers. So it's really not trivial for them to do that. Like, people say, just remove the phone numbers, and that's not how it works. The whole protocol, the whole API is built around the fact that you have a phone number. So they have to strip all that out. They want to keep the backwards compatibility. They do that. Yeah, they do that. Up to a certain time frame, like we had 6 months to migrate away, and I only realized too late. But they do that, right? So, like, this part of advertising, don't really like it, but it's nice that they have it. But I don't think Session at this point is at a point where it's a replacement to Signal. If you really want the privacy features that Signal gives you, I don't think Session can provide that yet. But it's an interesting player to look at, because they're doing some radically interesting and radically new things. Like, they use a peer-to-peer system. They use a blockchain, whether you like it or not, for certain consistency things that I might maybe approve of. I'm not a blockchain person, don't get me wrong. So this is an interesting one to look at. And then lastly, I realized the URL is made for 16.9 Beamer, sorry. Some things you might want to look at. So this talk is basically based around an article that I wrote in April with some updated things, because, well, Signal moves fast and breaks things. Something else interesting to read is Signal's blog, because they actually talk about all the technical innovations that they do, and it's really interesting to follow, and it's, for me, the primary source for information about it. If you're interested in zero knowledge proofs, Google Matthew Green illustrated Primer to Zero Knowledge Proofs, a very good article that goes into slightly technical detail about why they work and how they work and what you can do with them. It's really, really well written. And then in The Verge last week, I think there was a really good article, a really good interview with the new president of Sengel. I've read it yesterday on the train, highly recommended, very interesting stuff. So voila, I think that's it.
One question about your overview of instance messaging things. You didn't talk about Matrix.
I didn't talk about Matrix. Yeah, good point. Matrix is cool. I like Matrix, but not for talking with my mom. Yeah, that's basically it. Matrix for me is a replacement for something like IRC or Slack, but not for talking with, like, intimate conversations is not something I would have over Matrix. Why? Because I think the focus for Matrix is more on the big group aspect, the more the workplace kind of thing, open source communities, these kind of things. And yes, they do have end-to-end encryption, also for groups, but I feel like their focus is somewhere different. That's why I don't really consider it as an alternative. I use it every day. I really like Matrix, but not for intimate conversations. Okay, if that's a final question, then thank you for being here. Next, I guess.
Right.
So I'll try to do this quietly.
Is that your laptop?